we have a second order linear ODE and one solution is given. The first solution is given, and based on this we need to find a second linearly independent solution y2. Okay, so let's assume in this way. Let second solution y is y2, but I wanna write this y is just a variable times the first solution. Okay, it won't be constant time the second solution, first solution. It will be some variable, let's say v, unknown, to be determined, times given solution y1t. Okay, let that be a second solution. Since we are multiplying by a function, not a constant, this y2, this second solution will be linearly independent to first solution. Okay, now since this is also a solution, we can plug this into here. Okay, for we need to find y prime. So here we got a product of two functions, that's second solution. So let's find the first derivative y prime using product rule. I'm dropping this t, so this will be b prime y1 plus b y1 prime, and second derivative y double prime. Let's use product rule here and here. So b double prime y1 plus b prime y1 prime plus another product rule b prime y1 prime plus b y1 double prime. We can combine these two terms. So this is b double prime y1 plus 2 copies of b prime y1 prime plus b y1 double prime. Okay, now let's plug these into the ODE. So here we got y double prime, which is here, b double prime y1 plus 2 b prime y1 prime plus b y1 double prime plus p times y1 prime. So p times y1 prime, y prime is here, sorry, this, which is b prime y1 plus, we need to distribute p because we are multiplying by p here, p b y1 prime, b y1 prime plus qty. So this is y here, qty plus qty is just v y1. Okay, that equals 0. And we know that y1 is a solution, it's already given. What does that mean? That means y1 satisfies this equation. So if we replace y by y1, then we get this equals 0. y1 prime pt y1 prime plus qt y1 is 0. Okay, that's the meaning of solution. Solution means when we replace y by y1, then it's 0. So let's use that fact. Here is y1 double prime, y1 prime and y1. From these three terms we can factor v out. Okay, y1 double prime plus v out, so p y1 prime plus v out, so q y, and this collectively is 0 because y1 is a solution, so the whole thing is 0, by the way. That leaves b double prime y1 plus 2v1 prime y1 prime p, just drop t, just p, okay, let me write pt v prime y1 equals 0. Basically we are trying to find the value of v. Okay, as soon as we know the function v, our second solution will be v times y1. That's a second solution, and y1 is already given in this question. So let's go down here from these three terms. Okay, so this is just v prime, not v1 prime. Okay, this is v prime coming from here. From the last two we can factor v prime out. So this is v double prime y1 plus v out, v prime in fact, 2y1 prime plus p y1 equals 0. Okay, now we don't have a term containing v. We only have v prime, v double prime. Okay, first derivative, second derivative. Now we can reduce the order here. That's why the name reduction of order. Let u be just v prime, and then this second order ODE can be made a first order ODE. Okay, if we do this, then this star becomes a first order ODE. V double prime means u prime y1 plus, this is now u, 2y1 prime plus pt y1 equals 0. Now we want to find u first, and u is v prime. From there we find v, and we go back all the way. So let's move this second term to the other side. U prime y1 equals negative u 2y1 prime plus pt y1. Okay, now let's separate the variables, kind of bring u to the left side and move y1 to the other side. So u prime over u equals negative, let me put on the bottom and separate at the same time. So negative 2y1 prime over y1, negative 2y1 prime over y1, distribute negative, and pt y1 over y1, so cancel this pt. Okay, now integrate both sides with respect to t. When we integrate, u prime, so this is natural log of u. Same thing here, y1 prime means natural log of y1. Now integrate, we have no information, so just negative pt dt, because we don't know about p. This is unspecified. Exponentiate both sides, so we get u equals e raised to 1 minus integral pt dt, u equals n plus c, by the way, but we are just looking for one function, so we may take c equals 0 to make things simpler. And as we know, this negative 2 can be put here, so this e and natural log cancel. Y1 raised to negative 2, which is 1 over y1 squared. And when we write square, we don't need absolute value anymore. Okay, negative 2 power means 1 over y1 squared times e raised to this, e raised to negative pt dt. Okay, when we separate this exponential, it becomes a product. Now u will be plus minus, but we just need one u, so I'm going to take positive. Okay, so this implies u as a function of t equals plus minus, but I'm just taking plus for now, 1 over y1 squared times e raised to negative pt dt. Okay, now with this u, if we go back here, that's v prime. Okay, so that is, in fact, u means v prime is this, 1 over y1 squared times e raised to negative pt dt. then we can integrate both sides with respect to time t. Then we get v as a function of t equals integrate. And these are unspecified functions, so all we do is integral 1 over y1 squared e times e negative pt dt and whole dt, because this will be a function, plus c. Again, I'm just taking c equals 0 because we just need one function v, so plus c is not needed. So with this v, now we have a second linearly independent solution, because y second solution is vt times y1. Okay, we just found v and we multiply by given solution un. So thus second solution y2 is given by y1 times v. So v times y1, I'm writing y1 first, times v, and we just found v. Okay, v is here, y1 times 1 over y1t, that's the given function, given solution is squared, times e raised to negative dt plus c. We don't need that part. So basically you can take this as formula, and when y1 is given, you can find y2 second solution using this formula. Okay, final.